Good day, everyone. This is Dr. Masalla from Monomas Preferred University. I'll be take you through this lecture of organic molecules. When you hear someone talking about organic, just know that we are talking about the life. So organic molecules, in other words, you can say that these are molecules which we shall found in living organisms. These are molecules which you shall find in living organisms. Every living organisms that is there, you shall find these molecules. We say that these molecules are typically hydrocarbons and are attached to other primary elements such as nitrogen and oxygen, and sometimes also phosphorus and phosphates in lipids or lipophospholipid. There are four categories, major categories of these organic molecules, which we can say the four categories can say that may you guess them, or may you use your information from high school to say them. We have carbohydrates, we have proteins, we have lipids, and we have nucleic acids. So these are the major categories of organic molecules. If you see there, we have carbohydrates, proteins, lipids, and also nucleic acids. So carbohydrates are known for the energy source of living things. Proteins are known for the building of a living thing. Lipids are known of insulation, and also nucleic acids have been known of to control the genetic material. Because when you see DNA, you know that is you be talking about genetics. But the question will come and say, state the four major categories of organic molecules. You need to be in a position to state them. That you have carbohydrates, you have proteins, you have lipids, you have nucleic acids, you have DNA, and you have RNA. The main the carbohydrates, you are going to take them one by one. We're going to start with carbohydrates. I have a video talking about nucleic acids, and also talking about proteins and also lipids. So you may go and watch them if you didn't watch them. So the name of carbohydrate means a hydrate of carbon. A hydrate of carbon, it means hydrate. It means it involves water. So chemically, we can say that carbohydrates are organic molecules in which carbon, hydrogen, and oxygen bound together in the ratio of CX, H2O, H2O, and Y. You can see that this part, let me highlight here. I'll use a red ink. This part here is a what? Is an oxygen. This part here is a what? I mean, is a water. I'm sorry for that. Is a water. So that's why I say that they are hydrates of what? Of carbon, because they carry the water. Because they carry the water. And the other thing that we need to understand is that these X and Y values, you see this X and this Y values which I'm indicating the screen, they're just numbers. They show numbers. What makes up the carbohydrates? This is the question that we can ask and say, what makes up these organic molecules which we call them the hydrates? The hydrates, I mean the carbohydrates are made up of units of sugar. These units of sugar are called, the units of sugar which make the hydrates are called the saccharide. They are called the saccharide. So if you don't want to say sugar, you can say saccharide unit, or sugar unit, say saccharide unit. So sugars are going to come together. Let's assume that is sugar A. This is a saccharide. It's going to mix with sugar A again, then mix with sugar A again. So look at this. When sugar A is alone, when sugar A is alone, this sugar is called a saccharide. And because it's alone, we therefore use the word what? Mono. Mono means what? One. So this is going to be monosaccharide. When there are two like this, it's going to be called disaccharide. Di means what? Two. When there are like this, or when there are many, let's assume that this cycle is going to continue having many sugars, many. So this is going to be called a polysaccharide. So mono, I want you to understand this definition. Mono means one. Saccharide means sugar. So it's going to be one sugar. Di means two. Saccharide means sugar. It's going to be two sugars. Poly means many. Saccharide means sugar. It's going to be many sugars. Many sugars. Let me rub off my screen so that you can see the following notes easily. Then we continue and we say that a carbohydrate may contain one or more sugar units, which I was describing about. A single sugar is mono and is a monomer. A monomer is sort of a building block to a polymer. So you start up with the monomers first. After you start up with monomers, then your monomers is going to increase to disaccharide. So disaccharide is going to be a polysaccharide, and is made that are going to polysaccharide is going to we're going to have many sugar units. You're going to have many sugar units in the polysaccharide. So we can say that simple sugars are so sweet in taste. Why? Because they are absorbed quickly, because they are so simple, they are absorbed quickly. Therefore, the body uses them to release energy. The body uses them to release energy. So we are going to talk about the pharmacological effect of these simple sugars when you go in higher levels of biology. This is why now we're going to look at the importance and how sometimes drugs can be formulated to be absorbed quickly so that they can have a good onset action of that. The monosaccharides. Let us look at the monosaccharides. We say that they are monomers. It means that they are the building blocks of a higher carbohydrates. For you to get a polymer, you need to first start with what? You need to first start with a monomer. I mean, let's look at this slide below. Example of monomers. Monomers, which are monosaccharides here, because we're talking with sugar. And if you are talking about the proteins, yes, you are going to have monomers, but those monomers are not called monosaccharides. They are going to be called amino acids. When you talk about nucleic acids, those monomers are not going to be called monosaccharides, but they are going to be called nucleotides. You need to know that a nucleotide is whereby in my video I explained that it is going to have a nitrogenous base, a pentose here, and also a phosphate group. But there's a nucleoside and a nucleotide. You need to be able to differentiate these terms. A nucleoside is whereby you have a sugar and a base, sugar and the base, and you don't have other features. So let us look at the examples of monosaccharides. I always encourage my students to be able to draw a glucose, and to be able to draw a galactose, to be able to draw a lot of things. So the difference between a glucose and a galactose is seen in this what can you call in this sector, whereby you say a glucose is going to have a OH below, and the galactose is going to have an OH up. And this sector just shows which type of glucose is this, and this sector which shows a type of galactose is this. It can be D glucose and L glucose. And this is the fructose. Fructose, we can see that it has how many carbons? You may count the carbons of fructose here, and you say you state the number of carbons. So what we're saying that these molecules, these three molecules, glucose, galactose, and fructose, are monomers that have been needed to make disaccharides. And sometimes they can be joined numerously. Numerously, it means a lot, like beta 1,4, beta 1,6 glucose. They can be joined and they make polysaccharides such as uh, cellulose, starch, chitin, and many more, and many more. So now, because we say that these are monomers, it means monomers are the ones which are going to make disaccharides. And disaccharide is the combination of two monosaccharides. Look, I want you to understand this point. You first start with a monomer. After you start with a monomer, that monomer is going to yield the what? A disaccharide. A disaccharide is going to yield what? A polysaccharide. Yes, there are oligosaccharides there that you may in deeper biology you are going to learn about, but now in this level you are going to know that we are from disaccharide, you go straight to to polysaccharides. Let's look at that. Saccharides. They are made up of combination of two monosaccharides. These are two monosaccharides and could be the same or different. So it depends. You can take glucose and glucose or glucose and galactose. These monosaccharides can be the same or sometimes they can also be the different. They can also be different. As you can see, these are just they are made up of monosaccharides. Mean that you need to bring two monosaccharides. I was explaining later. I said that those monosaccharides sometimes they can be the same. They can be what? They can be different. So example is sucrose. Do you know sucrose? Again, you need to know that you identify these sugars by OSE. The table sugar consists of glucose unit bonded to fructose unit. You can see that is a glucose there, is a fructose unit there. They are different units, but all of them they can make a disaccharide. I forgot to tell you something. Monosaccharides are absorbed quickly, but if you have a scenario whereby you are giving a disaccharide and a polysaccharide, which one are going to choose? Which one would you choose when the question asks you that which one is absorbed quickly? We are going to choose the one which is uh, in simple. Polysaccharides are complex than disaccharides. Disaccharides are complex than monosaccharides. The when you bring the monosaccharides together, there is a bond. They are going to react actually, and there is a bond which is going to be formed there. And the bond which is going to be formed there is called glycosidic bond. Glycosidic bond. And multiple questions are going to be asked. Which bond is being formed when you bring a glucose and glucose or monosaccharides together, or glucose and galactose together? You know that when you bring glucose and fructose, you form a sucrose. So a sucrose is a disaccharide sugar. Is a is two sugars together. It's formed by two sugars together. That's why I say it's a disaccharide sugar. The bonding results in loss of H2O molecules. So when a glycosidic bond occurs, water is being released. What types of reaction is this? You use your chemistry knowledge and answer it. And you say, okay, water has been released. It means it is a condensation reaction. Condensation reaction. So formation of a disaccharide. How is a disaccharide formed? So it depends. In the last the examples of disaccharides that are there with which you should study for now before you can go to higher levels is sucrose. Sucrose, you say that you are bringing a glucose and the what and the fructose. You make sucrose, and sucrose is this table sugar, and the bond between that is a glycosidic bond. Now let us take example of the other what do you call this disaccharides? This like disaccharide, you are here, you are bringing uh glucose and uh, glucose. Glucose and glucose, we say that they are what? They are glucose and glucose, the same monomers. Because we say that the formation of disaccharides, it depends. You can form them when the monomers are the same, or monomers in here are what? Are different. But what you need to take into consideration is that there should be a monomer, one monomer, and one monomer. And then you form something like this, which is a dimonomer or a disaccharide. It means that there are two sugars together. There's this sugar and there's sugar together. And that sugar together is going to form a disaccharide. And maltose and lactose are disaccharides. Look, when you react, you need to know this uh, reaction, that the H from one monomer and the OH from one monomer, they're going to bind together and form the H2O. Why? If you see a reaction whereby water is in the reactant, that is a condensation reaction, because water had to be released from this original system. The same applies to lactose. So this bond which takes place here, the bond which takes place here, you can say the bond which takes place here. Why? Because a monomer means a monomer is called the glycosidic bond. It's called the glycosidic bond. So let us look at the polysaccharides. So the polysaccharides consist of hundreds of units of monosaccharides. When you bring this glucose 1, 2, 3, until a lot of glucose, you're now going to form what you call a polysaccharide. And mind you, actually will be linking glucose and glucose, glucose and glucose. You're going to have many glycosidic bonds, many glycosidic bonds. So polysaccharides, we can say that are not soluble in water. Why are not soluble in water? It's because we see that they are complex. Guys, what is digestion? Digestion is a process whereby you break down large, insoluble, complex into soluble, small. You see, now because this one are what are complex and are going to be insoluble in water. For polysaccharides, we can say that the monosaccharides units may be the same or different. Polysaccharides, the same way that you can make disaccharides, you can make them from same molecules, or sometimes you can make them from different molecules. And we say that when they are same type, they are called the homopolysaccharide. The e.g., whereby in starch, in cellulose, you just use glucose, many thousands of glucose to make starch. So they're called homopolysaccharides. And the homo means the same. And now, because sometimes we may have different polysaccharides, we may call them heteropolysaccharides. An example of heteropolysaccharides, we have lignin and we have pectin. So important polysaccharides that you need to discuss is starch and glycogen. You're going to read starch a lot about starch, know a lot about starch, then go to cellulose and know about cellulose. After cellulose, you go to chitin and know about chitin. So this is the end of our lecture. I'm Dr. Masalila. You may help me at 76608-201. So I'm trying my best to explain the BIO111 notes to you, so that when you are reading alone, you know what really is taking place. I would like for you to subscribe for my page and to share to my page to any friend of yours. May the Lord Jesus Christ protect you, guide you for your daily lives. May you be established.